Okay, now today we're going to do conjunctions or disjunctions and graph the solution set that's not empty. So let's take a look at our 4 example problems here. We have 4 problems, and we're going to look at the ands, the one that had the word and in here, and these are called conjunctions. Okay, so those are conjunctions. The or statement, the ones that have or in here, mean either one of the other can be true, and those are disjunctions. So now what we're going to do is we're going to graph the solution set of each. Now to graph them, what you do is you write the, graph the line, okay, and all you need to do is put the endpoints on the line. So my endpoint for -1, z greater than -1, z less than 3. All I'm interested in is the -1 and the +3. Get them on the graph as you need them, right where they belong. When you have greater than or less than, no equal sign, then you're going to use hollow dots or endpoints, okay, for them. I know that z is greater than -1, so I'm going to draw a hollow dot around -1. Greater than means it's to the right of, so I'm going to draw an arrow all the way to the right of there, and that is just the graph of z is greater than -1. But I have to also consider that the and says I have to have both of that plus z is less than 3. Well, less than 3 means I have not included 3, so I have to take 3 out of the set, and I have everything less than 3. Now, where these two lines intersect, or basically what they have in common, the points on the graph that they have in common, are right in here, between these 2 points. And that would be the graph of that conjunction. Now if we slip down and do a disjunction, like number 4, we have our number line. We're going to put our endpoints on there. So let's take this out of here. We'll put our endpoints, and we're going to deal with 1 and 1. So we only need 1 point here, and that's +1. Now p is going to be greater than 1, so we have p greater than 1, so the red is p greater than 1, and our green says or p is less than 1. So the green says p is less than 1. Now, what you're going to look for is, since you have an or, is I'm going to look for something that is either or, one or the other. It's got to satisfy either this one or this one. Now, the things that matter here are everything but 1. So everything up here satisfies, will make this statement true, and everything down here will make the statement true because it is a disjunction. It's an or. Okay, next, here's another disjunction, number 6. Now when we have greater than or equal to or less than or equal to, we have solid dots or points on our graph. Okay, so that's how we're going to do those. So let's get rid of these, and we'll go back and we'll do those number lines. So number 6, I plot my 2 endpoints, -1 and +3. -1, +3, and then y is greater than or equal to -1. So greater than or equal to means I can include -1, and it's greater than, so it's to the right. So the red is y is greater than or equal to -1. Now, y is greater than or equal to 3 means I'm going to include 3, and it's greater than or equal to 3. Now, since this is an OR situation, it means no matter what point I choose anywhere, it makes the statement true on this graph. So really, my graph becomes, includes -1 and goes on forever this way. And that's the whole graph of the disjunction. Next, we have another conjunction with an and. So we're going to do that one. W is less than 0. We have our number line. We have 0. Our other point is +4. Put them on the number line. W is less than 0. I'm going to do these in 2 colors. Less than, but it's not equal to, so it's a hollow dot. Less than 0. Greater than or equal to 4. Oops, gotta change that to green. Greater than or equal to 4 means I'm going to color this in with green, and it's going to go on in this direction. Now, because it's an and situation here on this problem, I need something where I have a point that has both red and green there. A point up here will only have green in it. A point down here will only have red in it. So I can't find any point that makes both of those statements true. So my answer for this one would be the empty set, which we usually use 2 brackets with nothing in between, or you can draw a little all with a circle through it, or you can also write no solution. Okay, now we have some problems here. And what we're going to do is we're going to look at them and say, what is this problem? Is it a conjunction or a disjunction? Well, here's how this is read. When you have 2 symbols like this, 2, it doesn't make sense to say 2 is greater than y plus 2, which is greater than or equal to 0. That's a little confusing. So how you read these is you start with what's in the middle. So you start with y plus 2. Well, since even though this says this sign right here says is greater than, we're going to read it as y plus 2 is less than 2, right? So what we're going to write over here, we're going to split this up because this is actually a conjunction. So we're going to take this part of it and we're going to write it over here as 2 is greater than y plus 2, or we could also say y plus 2 is less than 2 over here. And then we're going to split it up over on this side. We're going to take the y plus 2, pair it up with the other sign, and we're going to make another equation over here. Y plus 2 is greater than or equal to 0. Now I have 2 different equations, and because this is an and situation, this is a conjunction. This means I have to solve both of these down, and I have to find something that they have in common. So what I'm going to do is I'm going to subtract 2 from both sides, and I get 0 greater than y. So I have one piece of my and conjunction, and over here I'm going to subtract 2 from both sides, and I get y is greater than or equal to -2. Now I have to graph both of these things on the same number line. So I'm going to draw my number line, just like before. We're going to graph our 2 points. We have a 0 and a -2. So we're going to put -2 here, -2, and 0 here. And now what we're going to do is we're going to figure out what we need to do, whether we need to color them in or not. So, since this is a conjunction, I have to find this spot right in here where both I have red and green, where that makes both of these things true. So 0 is greater than y, or y is less than 0, means it's not going to include 0. So the red side, less than, y is less than 0, goes here. Okay? And on the green side, we have greater than or equal to -2. Well, greater than or equal to means I color it in because it's equal to, and it's greater than, so it's the green. And now what I'm looking for is something in between that actually has both red and green included. Well, I have to include the 2 because remember the 2, -2 I mean, because the -2 really is red also because this arrow goes on forever. So -2 is involved. And it goes all the way up here and it stops right before it gets to 0. So there's the graph of that conjunction. Okay. So you can see that you have to split these these things up. Conjunctions and disjunctions have to be split up into 2 separate problems. Now let's skip down to this disjunction and see how we can do that. This conjunction is done the same way as number 10. So now let's set this up. In this case, we have 2 separate inequalities. We have 3k plus 7 is less than 1, and we have 2k minus 3 is greater than 1. So we're going to set up 2 separate, it still has to be separated, but this is an OR situation. That means either one of these could be true. So let's start with our 3k plus 7 is less than 1, and let's solve this side. So we subtract 7 from both sides, minus 6 over here, and 3k over here. Divide by positive 3, which means I still don't have to flip that sign, and I get minus 2. So k less than -2. And now when I come over to this side, I write this equation, the green equation, over here, 2k minus 3 is greater than 1. Solving this, add 3 to both sides. I haven't done anything that makes me switch that sign because remember, it's only multiplying or dividing by a negative number. I'm going to divide by a positive 2, which still gives me k greater than 2. Now that I have both of my situations, I'm going to draw my number line. And I'm going to plot my 2 endpoints. I have a positive 2 and a negative 2. So here's minus 2, and here's the positive 2. Now, k is less than -2. Less than is not equal to, but it's less than, so that's to the left. Okay? And over here, k is greater than positive 2. So it doesn't include positive 2, and it's greater than positive 2. So here's the disjunction. Now, because it's an OR, it means I can either be over here with my answer or over here with your answer. And you can check these things to make sure that they make both things true. You can choose -3 and plug it into both of these inequalities and it will make it true. You could also pick a positive 3 or a positive 4, plug it into both inequalities and it will make the statement true, because it'll make one or the other true. It won't make them both because it's a disjunction. Okay, here's a couple more problems. A little more, just slightly more advanced. Let's take number 16 at the top. 2x plus 3 is greater than 1, or, so we have a disjunction already, 5x minus 9 is less than or equal to 6. So solving both separately, and it doesn't really matter what color I use because I have to do both of them. And because it's an OR, it could satisfy either this one or this one to make the statement true. So over here on the left, we're going to subtract 3 from both sides. I get a minus 2 less than 2x. And I didn't multiply or divide by a negative. I'm going to divide by a positive 2, which gives me x is greater than negative 1. Over here, I'm going to add 9 to both sides. I still haven't done anything that's going to flip that sign, right? So 9 plus 6 is 15, 5x. Divide by a positive 5, x is less than or equal to 3. So now I can draw my number line, plot my 2 points. I have a positive 3 and negative 1. X is greater than negative 1 is here, or x is less than or equal to 3. Less than or equal to, color it in, less than or equal to 3. Notice I'm going to get that negative 1 anyway. So negative 1 will make this side of the true, yet it will not make this side true because it's got to be greater than negative 1. Okay? Now, let's try the conjunction, and we're going to change this to and. Let me get rid of some things here. Okay, we have 2x plus 3 is greater than 1, and means both things have to happen to make this true. 5x minus 9 is less than or equal to 6. Now, I'm going to solve these differently. I'm going to subtract 3 from both sides and divide by a positive 2. Okay, and over here, going to add 9 and divide by a positive 5. And I didn't do anything to goof up the signs at all. Now I'm going to draw my number line, and I should have solved one in green and I didn't. And I'm going to plot my 2 points, negative 1, positive 3. And let's do this one in red. Let's do this one in green. Let's just pretend I drew those in green. Okay, so x greater than negative 1 over here, greater than, not equal to, means I open it up and I draw this line going on forever this way. Now over here, x is less than or equal to 3. It's equal to 3 or less than 3. So I have this going on. And now what I'm looking for, because I have an and, I have to have both green and red in the picture. So 3 is included, because remember this red line goes on forever. Okay, so 3 is included here. But since 3 is included, I don't have any green over here beyond 3 to the right of 3. I just have my red and green in between the two. So really, this is the only thing that is the graph of that conjunction.